So, good evening, all of you. So, we were discussing what will be force experienced by the charged particles when there are multiple charges. So we have discussed the superposition principle. So you have to apply Coulomb's law and superposition principle. So in last lecture, I have given you one example to solve. Have you solved it? Let's see. So that example was consider the charges q and minus q placed at the vertices of an equilateral triangle and equilateral triangle as shown in figure. So let us consider that you have an equilateral triangle this is an equilateral triangle. Take this charge to be q, this charge is also q, and this charge is minus q. And their sides are L, these lengths are L. So what is the force on each charge? What is the force on each charge? What is the force on each charge? So let's take, this is charge 1, this is charge 2, and this I'm taking as charge 3. And you can take, let's say this point is A, I'm taking this point to be A, this point to be B, and this point is C. So you have to find force on 1, 2, and 3. So let us first see what will be force on this charge Q. So this will experience force because of Q and minus Q.
Yes, sir.
So both charges are positive. So what will be direction of force on 1 due to 2? So this will be the direction of force. Let's call this as F12.
English వేరే.
Please mute yourself. So this force is F12. And what will be magnitude of force? What will be magnitude of force F12? So this will be 1 by 4 pi epsilon naught. Magnitude is, I'm taking Q is square by L square. Okay? And then what is force experienced by this charge Q due to minus Q? So this charge Q will experience force in the direction of minus Q. So I am writing this to be force F13 है कि नहीं? ये फोर्स कितना होगा? F13. So magnitude will be same. This magnitude is also same. ठीक है? Magnitude of F12 is F13. Let's write this magnitude to be some constant value F. कोई F value हम ले लेते हैं. So what will be resultant of F1 and F12 and F13? इन दोनों का resultant क्या होगा? तो ये एंगल कितना है? बिकॉज इट्स इक्विलेटरल ट्राइंगल, तो ये एंगल है 60 डिग्री. तो ये कितना होगा? 120. ठीक है. So resultant of what, because magnitude is same, so resultant will be at, this is F1 and this angle will be 60 degree. This angle will be 60 degree. ठीक है. So what will be resultant of F1? F1 का magnitude कितना होगा? Can you find the resultant of F1? Let's find F1. So F1 is given by magnitude of F1 square is given by F12 square plus F13 square plus 2 F12 F13 cos 120 है कि नहीं? तो ये वैल्यू आप F लिख लो. ये क्या हो जाएगा? F स्क्वायर प्लस F स्क्वायर प्लस 2F स्क्वायर और cos 120 क्या होगा? Cos 120 degrees, cos 90 plus 30, so minus sin 30. So this value is minus 1 by 2. So into minus 1 by 2. So ये simply F square हो जाएगा. F1 square is F square. So F1 is, magnitude of F1 is simply F. और इसका डायरेक्शन क्या होगा? डायरेक्शन इज this will makes an angle 60 degree with this line, or you will see this line will be parallel to this line. Yes or no? This line is parallel to this line. So if you write the force F1, this is magnitude along direction will be BC. ठीक है? Force of F1 will be along BC. Unit vector. This direction is along BC. So you have magnitude F and direction will be along this line BC. Now F value is Q square by 4 pi epsilon naught L square. ठीक है? तो ये Q चार्ज पे होगा, that is charge 1. Force experienced by charge 1. ऐसे ही इस पे क्या फोर्स होगा? देखो, तो ये फोर्स हो जाएगा F21 और ये फोर्स हो जाएगा F31 और मैग्नीट्यूड सेम होगा इसका भी, और इसका रिजल्टेंट हो जाएगा F2 और ये भी 60 डिग्री बनाएगा. ठीक है? सो यू विल सी मैग्नीट्यूड ऑफ F21 F12 is same. F21 is same as F12. So magnitude of F21 is same as F12, or that is F, and magnitude of F31 is also magnitude of F13. ये वैल्यू भी F होगा, ठीक है। और इनका रिजल्टेंट क्या हो जाएगा इन सेम वे, जस्ट लाइक दिस एंगल इज, if you calculate the resultant of F2, so magnitude will be F, और ये डायरेक्शन क्या होगा, ये AC के अलोंग होगा, डायरेक्शन इन द डायरेक्शन अलोंग AC, ठीक है। मैग्नीट्यूड एंड डायरेक्शन ऑफ फोर्स एक्सपीरियंस बाय चार्ज Q, सेकेंड चार्ज, प्लीज चेक।
सर F32 होगा या F31?
नहीं, F32, yes, this is F32, yes, please correct it, this is F32. So this is F32 is, you can simply write it F, and that is same as F13 also. So F32 is also F. F32 is F. This magnitude will be same. So that, because it is 2 and 3, so you can write it as F23. You can write it as F23. F, this will be given by magnitude of force F23 is F. इसको आप F23 लिखो। This is F23. Now in same way, find the magnitude of force on third charge. Try करो. What is the magnitude of force on third charge? Let's calculate. ठीक है, तो अब देखो ये -Q और +Q, ये फोर्स की डायरेक्शन क्या होगी, बिकॉज दिस इज -Q, सो इट विल बी अट्रैक्टेड टुवर्ड्स +Q, ये +Q की तरफ अट्रैक्ट करेगा, तो इसको हम लिख सकते हैं F31, ठीक है। और इसके कारण क्या हो जाएगा, ये F32, F32. So again, magnitude of F31 is same as magnitude of F32, और ये भी F के बराबर होगा क्योंकि ये वैल्यू चेंज नहीं हो रहा है, Q square and distance is L square. So this magnitude is also same. Now see, अब इन दोनों का रिजल्टेंट क्या होगा, ये 60 डिग्री पे है, तो ये इसका रिजल्टेंट इन बिटवीन होगा, लेट्स से दिस इज F3. यस और नो? इन दोनों का रिजल्टेंट क्या होगा, F3, और F3 फिर से आप ये फॉर्मूला यूज करोगे तो क्या हो जाएगा, F3 स्क्वायर इज इक्वल टू F31 स्क्वायर प्लस F32 स्क्वायर प्लस 2 टाइम्स F into F cos 60, because this angle is 60 डिग्री, है कि नहीं। अगर दो वेक्टर ए और बी उनका एंगल थीटा है तो रिजल्टेंट क्या होगा, आर स्क्वायर इज ए स्क्वायर प्लस बी स्क्वायर प्लस 2ab cos थीटा। तो मैं डायरेक्ट फॉर्मूला यूज कर रहा हूं, तो ये वैल्यू क्या हो जाएगी, cos 60 is 1/2, so this is F, this is also F. इसको कैलकुलेट करो, क्या वैल्यू होगा, दिस इज दिस विल बी 3f² है कि नहीं? 1/2 f² प्लस f² प्लस f², 3f², और ये वैल्यू हो जाएगा, देन f3 इज √3f. Magnitude is √3f, and let's say this direction is, इसको हम ये डायरेक्शन n कैप ले रहे हैं, so that will be its f3 को आप लिख सकते हो on this value. Yes or no? Where f is q² by 1/4 pi epsilon naught L². Is it clear? What will be f1? Magnitude is same as f. f2, direction of f1 is along BC, in this direction, along the direction of BC. f2 is along the direction of AC, and f3 is in this direction. So that is the force experienced by each charge. Now in this question, there is a one important result, that if you add vector sum of f1 plus f2 plus f3 is 0. You can check that f1 plus f2 plus f3 is 0. कैसे चेक करोगे? Check that sum of these three vectors, vector sum is 0. तो अगर मैं इस पॉइंट पे देखूं, आप एक बार इक्विवेलेंट ड्रॉ करो. लेट्स सी, आई एम रिप्रेजेंटिंग ऑल वेक्टर्स एट पॉइंट ए. इस पॉइंट ए पे हम रिप्रेजेंट कर रहे हैं. तो ये f1 की डायरेक्शन होगी, दिस इज f1, और f2 की क्या डायरेक्शन है? f2 की डायरेक्शन ये c है, f2 की डायरेक्शन ac के अलॉन्ग होगी, ये f2 होगा, है कि नहीं? और f3 क्या होगा? इस लाइन से ये 30 डिग्री एंगल बना रहा है, तो ये f3 होगा. यस और नो? और f3 का मैग्नीट्यूड कितना है? √3f. दिस एंगल इज 30 डिग्री और ये एंगल भी 30 डिग्री. f1 का मैग्नीट्यूड कितना है? f. ये मैग्नीट्यूड है इसका f, और इसका मैग्नीट्यूड भी है f. अब इन तीनों का वेक्टर सब क्या होगा? इस f को अगर आप इस डायरेक्शन में रिजॉल्व करोगे तो क्या होगा? f cos 30, और इसका भी कंपोनेंट क्या होगा? f cos 30, और इसके परपेंडिकुलर डायरेक्शन में कंपोनेंट क्या हो जाएगा? f sin 30, और ये कंपोनेंट भी क्या होगा? f sin 30. तो ये तो कैंसिल आउट हो जाएंगे, है कि नहीं? और ये कंपोनेंट क्या हो जाएगा? 2f 2f cos 30, ये वैल्यू हो जाएगा, cos 30 is √3/2, so this is √3f. तो ये कैंसिल आउट हो जाएगा बिकॉज दे आर इन अपोजिट डायरेक्शन, और ये वैल्यू भी √3f है, अपोजिट डायरेक्शन में भी √3f है, सो रिजल्टेंट विल बी 0. क्लियर? So you should verify this condition, that vector sum of forces on each charge will be 0. Please check it. ठीक है, इज इट करेक्ट? सो नोट इट डाउन. So till now we talked about Coulomb's law, that is you can find the force between the two charges and more than two charges. अभी तक हमने इलेक्ट्रिक फील्ड की बात नहीं किया. नाउ वी विल डिफाइन व्हाट इज इलेक्ट्रिक फील्ड. So now we will talk about electric field. Let's see what is electric field. What is electric field? So now consider, let's say at the origin, this is the origin O, and where you have placed a charge Q. This is the origin, and at any point P, this is its position vector, and this is r cap. We have to define electric field at point P. So you know that if there is a charge Q, let's call this as a test charge. और इसको हम सोर्स चार्ज बोलते हैं. दिस इज सोर्स चार्ज. तो क्या होगा? ये टेस्ट चार्ज फोर्स एक्सपीरियंस करेगा, और ये फोर्स क्या होगा? 1/4πε0 Q into Q by R square R cap. According to Coulomb's law, this is the force. But if you remove this test charge, now let's remove this test charge. So what will happen? So what is at point P? अब अगर आप ये एज्यूम करो कि इस टेस्ट चार्ज को हमने यहां से रिमूव कर दिया, सो अब पॉइंट P पे क्या है? So that if you place charge Q, it experiences force. So we define the electric field around this charge Q. Even if this charge is not present, so you have to associate field with the source charge Q. So there is a electric field associated with the source charge Q, so that when you place this test charge Q, it will experience force because of that electric field. ठीक है? So we now electric field at point P as force per unit test charge. So this electric field doesn't depend on this charge. Even if this charge is not there, there is a field associated with charge Q. And that electric field is force per unit test charge. और इसकी वैल्यू होगी 1/4πε0 Q by R square R cap. ठीक है? So this electric field due to charge Q doesn't depend on this test charge because this is force per unit test charge. So it depends on distance from the source charge to the point where you are calculating the electric field, and it also depends on the magnitude of charge Q. And if charge is positive, we say that electric field is in radially outward direction, because point charge Q has spherical symmetry, so it is radially outward direction. ठीक है? So this defines the electric field. If charge is positive, अगर हम इस चार्ज को पॉजिटिव एज्यूम करते हैं, सपोज यहां पे कोई प्लस क्यू चार्ज है, तो जो इसके कारण हम फील्ड रिप्रेजेंट करेंगे वो रेडियली आउटवर्ड डायरेक्शन में होगा, पॉजिटिव चार्ज क्यू। ठीक है, ये हम फील्ड रिप्रेजेंट कर रहे हैं बिकॉज ऑफ प्लस क्यू चार्ज, सो दिस इज रेडियली आउटवर्ड। इफ इट इज माइनस क्यू चार्ज, इफ दिस इज माइनस क्यू चार्ज, तो फील्ड ये क्या होगा, ये रेडियली इनवर्ड हो जाएगा। ठीक है, सो दिस इज द फील्ड due to plus q charge. This is radially outward and this is radially inward. Clear? Now in this definition, you know that because this charge q exert force on q, charge q exerts force on q, so this small q also exerts force on q, and they have equal magnitude but in opposite direction. But in order to define the electric field, we are assuming that this test charge is stationary. हमको assume करना है कि जो source charge है वो stationary है. So to define it in the practical way, we assume that this charge q is very small, so that force is also very small, so that it remains stationary. तो उस condition में हम जो electric field define करेंगे, we will see that in the limit q tending to 0, f is also small. We will take q to be very small, so that charge q, this charge q remains stationary. Under this assumption, we will define the electric field due to source charge, that source charge is not moving, so that you can define the electric field due to stationary charge. ठीक है? Is it clear? ठीक है? So that is the definition for electric field, that it is force per unit charge, assuming the source charge is stationary. So when charge q is very small, and then force will be finite, so this ratio will give you finite value of the electric field. Clear? So this is the electric field due to one single stationary charge. Now we have to find if you have a set of n charges, what will be field? So next is field due to multiple charges. Let's see field due to multiple charges. Field due to multiple charges. So again, we have to use the superposition principle. Write down the field due to individual charge. If there are n charges, so find field due to q1 separately, then q2. They are all vectors quantity, and then take their vector sum. So that gives the superposition principle. So assuming you have a charge q1, and this is point P. Point P, and this is position vector R1P. Then you have charge q2. So this position vector is R2P. And so on. If there are n charges, R and P. So find the electric field due to individual charges, then take vector sum, and let's say E is the resultant field. E is the resultant field. तो ये resultant field क्या होगा? Resultant field is vector sum of the electric field due to individual charges. Vector sum of the electric field due to individual charges. ठीक है? और इसको आप लिख सकते हो 1/4 pi epsilon naught. This is Q1 by R1P square और डायरेक्शन इसका आप ले लो R1P cap in this direction plus Q2 by R2P square R2P cap. ठीक है? QN RNP square and then you have RNP cap. तो ये इंडिविजुअल इलेक्ट्रिक फील्ड हो गया. And then you should write this electric field E as this will be 1/4 pi epsilon naught summation over I 1 to N QI RIP square RIP cap. This is the resultant field. And we have used the superposition principle. Superposition principle. You have to find electric field due to individual charges and then take vector sum. You will get the electric field due to multiple charges. ठीक है? So we have defined electric field due to set of n charges. So you know force between two charges and you know field due to single charge or field due to set of n charges. So note it down. ठीक है? Now take example based on the electric field. So let us consider write down an electron an electron falls through a distance of falls through a distance of 1.5 centimeter in a uniform electric field in a uniform electric field of magnitude 2 into 10 to power 4 Newton per coulomb. The direction of the field is reversed. The direction of field is reversed, direction of the field is reversed, keeping its magnitude unchanged, keeping its magnitude unchanged, and a proton falls through the same distance. Proton falls through the same distance. Proton falls through the same distance. Calculate the time of fall in each case. Calculate the time of fall in each case. ठीक है, तो पहले आप ये फिगर कंसीडर करो इलेक्ट्रॉन के लिए. So I am taking, this is the direction of electric field. इलेक्ट्रिक फील्ड की डायरेक्शन अपवर्ड है. This is the direction of the electric field, and electron is released in this case. So this electron will move in this direction. Let's say this is figure A, and in figure B, if you reverse the direction of the electric field, इसको हमने प्लस कर दिया और ये माइनस हो गया. ठीक है. नाउ कंसीडर अ प्रोटॉन हियर. अब प्रोटॉन ऐसे मूव करेगा. Positive charge moves in the direction of the electric field. Positive charge moves in the direction of the electric field, and negative charge moves in the direction opposite to the electric field. So this is for motion of electron, and this is motion of proton. Now you have to find the time of fall, and this length is same. Let's say this is h, and this h is given in this case 1.5 centimeter. ठीक है, ट्राई करो. लेट्स कैलकुलेट इट. ठीक है, तो क्या होगा? लेट्स सी द सॉल्यूशन. We have to ignore the gravity because acceleration will be very high for electron and proton. That point I have also discussed. So what will be the acceleration of electron here? So just see, force is mass of electron into acceleration, and this is E into E. Force experienced by the charges in external field is E into E, where me is mass of the electron. So what will be acceleration? So now what is the time taken to cover a distance h when initially it is released? So initial speed is 0. So here h is given by half AE. For electron I am writing AE into TE square. S is equal to, you have to use S is UT plus half AT square. So distance covered is given by this relation. U is 0. So H is half 80 square. For electron, I am writing E. So what is TE here? TE is given by under root 2H by AE. And this will be, this value is under root AE is E into E by ME. So this is twice H mass of electron by E into E. Now we know the H is 1.5 centimeter, mass of electron 9.1 10 to power minus 31. H is given. What will be H here? Put H is equal to 1.5 into 10 to power minus 2 meters. Mass of electron is 9.1 10 to power minus 31 kg. And this electronic charge is 1.6 10 to power minus 19 coulombs. And electric field E is given as 2 into 10 to power 4 Newton per coulomb. So you have to substitute these values, and if you calculate it, I'm writing the value. So this TE is approximately 2.9 into 10 to power minus 9 second. This is the time. 10 to power minus of the order of 2.9 10 to power minus 9 second. Now same thing if you calculate for proton. For proton, time taken will be what? Twice H MP by E into E. Everything is same except mass of proton. You know that this is 1.67 10 to power minus 27 kg. So this will be, this is, if you calculate the value by substituting all these values, this is 1.3 into 10 to power minus 7 second. So which one is greater? Now you can see time taken by the heavier particle is greater. Proton is heavier than electron. And this time taken by the proton is greater than the time taken by the electron to cover the same distance in a same electric field. Is it clear? So it will take more time in case of proton. But under free fall, if you compare with under free fall, if you are considering the effect of gravity, they take same time. Yes or no? So free fall under gravity. What is free fall under gravity? In this case, time taken by the proton is same as time taken by the electron. So it is independent of mass. Independent of mass. This is independent of mass. And if you calculate the simply acceleration of proton or electron, that I have already discussed. So I have just compared with the free fall under gravity. So it is independent of mass. But in electric field, you can see this is the condition that heavier particle will take more time to cover the same distance. Now what will be acceleration of proton? Acceleration of proton is E into E by mp. Just see this value. I think if you calculate this value, this is 1.9 and 10 to power 12 meter per second square. This is of the order of 10 to power 12 meter per second square, but G is 9.8 meter per second square. That's why you can ignore the gravity, because this value is very small as compared to this acceleration. So we ignore this gravity. Ignore G in comparison to acceleration because of the electric field. So must remember this particular example. Okay? Clear? Please note down. Is it clear to everyone?
Yes, sir.
So note it down. These are all standard results. So you should know these results, because they will directly ask question. These results, that what will happen under free fall? What will happen in this case? What will be the condition of time? Proton, electron, less than, greater than, or same. So that's why you should, these are the standard example and you should remember their results. Okay? Now take another example. Now we will see in one particular case, we have to find the electric field. Consider 2-point charges Q1 and Q2, 2-point charges Q1 and Q2 of magnitude 10 to power minus 8 coulomb plus 10 to power minus 8 coulomb and minus 10 to power minus 8 coulombs. Respectively are placed 0.1 meter apart. 1 meter apart. Calculate the electric fields. Calculate the electric fields at points A, B, and C as shown in figure. Okay? So let's draw the figure first. So this is one charge, this is another charge. This is Q1 and this is Q2. And points are, let's show the points. One point is A. A is this point. This point is A, and this is 0.1 meter. This is also 0.1 meter, and this will be 0.5 meter, and this is also 0.5 meter. So this is point A, and there is another point B here. This point is B, that is 0.5 meter away from Q1, and this point is C. So you have two charge Q1 and Q2 that are placed 0.1 meter apart. Q1 is plus 8 plus 10 to power minus 8 coulomb, and this is minus 10 to power minus 8 coulomb. So this value is
सर डिस्टेंस 0.05 नहीं हो जाएगा?
This is 0.05. Yes, you should. This will be also 0.05. Take it as 0.05. So this is 0.05 meter. And this is also 0.05 meter. And this is also 0.05 meter. So this is the 10 to power minus 8 coulomb, and this is minus of 10 to power minus 8 coulomb. Now you have to find the electric field at point A, at point B, and at point C. Let's calculate. Try to find the electric field. So you have to find field due to individual charge. So what will be electric field due to Q1 at point A? So this field will be in this direction. This is E1A. Or this is, you should write it as EA1. EA1. This is the direction. And what is EA1? This magnitude is given by 1 by 4 pi epsilon naught is 9 into 10 to power 9 into Q1 is 10 to power minus 8 coulomb by 0.05 meter square, 5 square. And if you check the value, this is 3.6 10 to power 4 Newton per coulomb. And what is EA2? EA2 will be in opposite direction. This is EA2. EA2 is also in the same direction. Why? Because this charge is negative. Yes or no? So charge will be negative. This charge is negative. Q2 is minus. So EA2 will be also in the same direction. And the magnitude of EA2 is also same. Yes or no? So what will be magnitude of EA? Resultant field is given by magnitude of EA1 plus magnitude of EA2. Is it clear? So if you add these two, so this will be 7.2 into 10 to power 4 Newton per coulomb. And what will be direction? Direction will be from B to from Q1 to Q2. From Q1 to Q2. So direction will be from Q1 to Q2. Is it clear? What will be magnitude and direction of the field at point A? Yes or no?
Yes, sir.
Or if you don't write Q1, Q2, towards right. Towards right. Towards right. Now find at B. In same way, let's calculate at B. Let's find field at B. So due to Q1 is positive. So this will be the direction. This is EB1. And what will be EB2? It will be towards this side. EB2. And then you have to see the resultant. So what is magnitude of EB1? So this is 1 by 4 pi epsilon naught 10 to power 9 into 10 to power minus 8. And what will be the length? Again 0.05. This and this value is 3.6 10 to power 4 Newton per coulomb. And what will be EB2? What is the magnitude of EB2? So now this will be 0.1 and this is plus 0.5. So this will be 0.15. So you will get 9 into 10 to power 9, 10 to power minus 8 coulomb. And this will be 0.15 meter whole square. Now calculate this value. Let's check this value. So this is given by, if you calculate EB2, this is 4 into 10 to power. Numerical value you have to check. Newton per coulomb. So which one is greater? EB2 is greater than EB1. So what is EB? Magnitude of EB resultant is in this direction. This is the resultant of EB. Here, this is the resultant EA vector. EA will be towards right and this will be EB. So this is also towards right. Yes or no? So check the value. Which one is greater? EB2 is 4 into, no, this is 4 into 10 to power 3. So this and this value is 36 into 10 to power 3 Newton per coulomb. So this is greater. So it means it
EB1 is
is,
greater.
so resultant direction will be opposite to this.
Towards left.
Yes, this will be towards left. This is resultant of EB. EB will be towards left. So that is given by magnitude of EB1 minus of magnitude of EB2. And this will be 36 minus 4, 32 into 10 to power 3 Newton per coulomb towards left. Towards left. Okay? So this is the electric field at point B. Now you have to see next is at point C. So how we will calculate at point C? Point C. So what will be electric field? You took Q1. So this field is EC1 and this field is EC2. So again, what will be magnitude of EC1 is same as magnitude of EC2, and this value is 1 by 4 pi epsilon naught 10 to power 8 by 0.1 whole square. So what will be this value? This is 10 to power minus 8. So this will give you 10 to power minus 2. So 10 to power minus 6, 9 into 10 to power 3. 9 into 10 to power 3 Newton per Coulomb. Now you have to find resultant of these two. Their magnitude is same. So what will be their resultant? So now this angle is, this is 60 degree. So this is 120. So resultant field is EC here. This will be the resultant field. And this is 60 and this is also 60. So if you resolve EC1 and EC2, so this component will cancel out. This component will cancel out. These two components will cancel out. So resultant field is in this direction only. Yes or no? So these two components will be of equal magnitude and in opposite direction. So resultant EC is, so resultant EC is given by EC1 cos 60 plus EC2 cos 60. Cos 60 is 1 by 2 because magnitude is same. So this is 1 by 2, 1 by 2. EC1 and EC2 is same. So this will be simply EC1 or EC2 because magnitude is same. And this value is 9 into 10 to power 3 Newton per Coulomb towards right. Towards right. ठीक है? And perpendicular component will be sine component. And this sine component EC1 sine 60, EC2 sine 60. So they will cancel out. So resultant will be towards right. And this is the component. So resultant EC will be EC1 cos 60 and EC2 cos 60. So in this way, using Coulomb's law and superposition principle, you can all find the force between charges and also electric field due to multiple charges you can find. So till now, we only talked about force between charges and field due to charges. Is it clear?
Yes, sir.
So
Yes,
any
sir.
doubt up to this point? यहां तक कोई डाउट है तो बताओ.
No, sir.
ठीक है? So in next lecture, we will further talk about field lines, number of field lines, and then we will define the electric flux. So other concepts we will discuss in next lecture. ठीक है? Is it clear?
Yes.
ठीक है? तो फिर बाकी नेक्स्ट लेक्चर में करते हैं. चलो फिर. ओके. थैंक यू एवरीवन. थैंक यू.
Thank you, sir.
Thank you,
Thank
sir.
you. Thank you.